All right, next up in section 12.0 on the review of polynomials, we're just going to continue our work on factoring in problem number 4. So we had done A through G in the last video, so we'll start here with H. We have x squared minus 6x plus 9. So this is a trinomial. There's no common factors across all three terms. So we'll set this up as the product of two binomials. And to get the x squared, I'll need an x and an x. And then for the 9, I need two numbers that multiply to a positive 9. So that could be a 1 and a 9, or a 3 and a 3. And the middle term is negative 6. So I need to build a negative 6 either from a 1 and a 9 or a 3 and a 3. Okay, and if I make both of the 3's negative, I see that I can do that just fine. Okay, so here then my factorization would be x minus 3 times, well, x minus 3. So this is a perfectly fine way to write that answer, but notice, of course, since the factor of x minus 3 is repeated, you can just as well write this as x minus 3 quantity squared. And this is just a little bit more compact. So I would accept either answer for a problem like this, but this last one again just has the benefit that it's a little bit shorter. Okay, cool. So then how about I? We got x squared minus 16. So here I can think about this as a trinomial whose middle term is 0x. So I can proceed just as above and say, well, I'm going to multiply out two binomials. I need an x and an x to build my x squared, and then I'm going to need, for the minus 16, two numbers that multiply to give me a minus 16. So ignoring the sign for the moment, I could have a 1 and a 16, a 2 and an 8, or a 4 and a 4. Okay, and my middle term now is a 0x. And so what I want, right, is to build a 0, right, out of one of these pairs, right? And again, I'm going to have to assign a positive and a negative to one because their product is a negative number. So giving that some thought, right, it's going to have to be this pair, the 4 and the 4, where I'm going to make one of these positive and one of them negative. So I'll say x minus 4 and x plus 4, okay? And we can easily check that this is working by just multiplying it back out. We'll get x times x is x squared. We get a positive 4x minus a 4x. There's your 0x middle term. And then lastly, minus 4 times positive 4 is our minus 16. So it works. Now, this particular problem, okay, is an instance of a more general pattern that I want to highlight over here, known as the difference of squares. And this is a really useful pattern we'll use from time to time. It says this, it says if you have an expression a and it's squared, and then you're subtracting from that the square of another expression b, you can factor that as the product of their difference, so a minus b, and their sum, a plus b. Okay, and we can easily check that this works by just multiplying out this right-hand side. So let's do it. We get a times a is a squared. Then I'd get a plus ab, then a minus ba, and then a minus b squared. Okay, and now a, b, and ba are really the same thing, right? Like 3 times 7 and 7 times 3 are the same value. That's what's called the commutative property of multiplication. Okay, and since we're subtracting here, these terms, in fact, will cancel out. And so we are left with the left-hand side of a squared minus b squared. So it works, okay? So now coming back real quick to part I, this is x squared minus 16. So we factored it up here, right, by thinking about it as a trinomial whose middle term was 0x, but you just as well can think about this as a difference of squares. I think it makes it a little bit easier, right? This is really what? X squared minus 4 squared, right? Because 16 is a perfect square. So this then would factor as, well, a minus b, and our a is x and our b is 4. So x minus 4 times a plus b, and that'd be our just x plus 4. Okay, so really useful. We'll be using this from time to time. Okay, and let's now look at j with this in mind, right? 4x squared. Well, that is a square. It's what? It's 2x quantity squared. Minus 9, well, that's 3 squared. Okay, and so now what I can do, once I observe, hey, this is something squared minus something else squared, I can just jump straight to the factorization, taking advantage of this difference of squares pattern. So that's going to be our 2x minus 3, there's our a minus b, and then our 2x plus 3. And that's it. All right, nice. Moving on, k, 2x squared minus 3x minus 9. Now this is a trinomial, no common factors across the board, so we can't factor anything out to begin. And the thing that really distinguishes k from some of the other trinomials we've seen, like say part A or part F, is this leading coefficient, right? The coefficient of x squared here is not 1, it's 2 in this case. Now the idea though nonetheless is really the same as what we've been doing. It's just that the construction of the middle term now can be a little bit more complicated. So for the 2x squared, what do I want? I need a 2x and an x. Okay. For the minus 9, ignoring the sign again for the moment, just the 9, well, two numbers that multiply to give me 9. I could try 1 and 9, or I could try 3 and 3. Okay, so now this is where the guess and check part is going to come into play when it comes to building this middle term of minus 3. Because notice now it's a 2x there and an x. Okay, so the placement of the pair of numbers in our binomials is just, it's going to work out to be slightly more complex for the middle term because of the 2 here. As opposed to just x and x. Well, in any event, let's just try, for example, 1 and 9 to illustrate what's going on. So if I try that, will this work? Well, the 1 times the x, our inside term, would just be x. And the 2x times 9, that would come out to be 18x. And can I assign, positives or negatives in some way to get that combination to work out to this middle term of minus 3? The answer there is no, of course, right? 18 is just way too big. Okay, so what I can do, I'm going to go ahead and just get rid of this. 1 and 9 is what is just not going to work, right? So let's try something else. Let's try, say, 3 and 3. So we try 3 and 3, and now this would give us a middle term of 3x, and then the outside term here would be 2x times 3 is 6x. And then again, we're asking, right, can I assign positives and negatives in some way to get that combination that would result to wind up being minus 3x? And the answer there is yes, I can. And the way how? Well, make that 6x a negative. So in other words, I'm going to need to make this, right, this 3 negative here because I need 2x times a minus 3 to give me that minus 6x. And then this 3x I need to be positive. And cool, that's going to do the job, right? Because there's my minus 3x, and that's exactly what I need. And there we have a factorization. Okay, so as you can see, yeah, might be a little bit more cumbersome to generate that middle term when your lead coefficient is not 1. But usually, you can land on it fairly quickly, especially if the coefficients here are not highly factorable, like 12 or 24 or something like that, okay? All right, cool. Moving on to L, 3x squared plus 10x plus 8. All right, well, approach it just the same way. We got another trinomial here. And so we're going to get what? Well, I need a 3x and an x to build my 3x squared. I need for the 8 two numbers that multiply to give me 8, so it could be a 1 and an 8, or a 2 and a 4. So again, I can just try, say, a combination like, I don't know, what would 1 and 8 look like? Well, too big, right? I can immediately see that just from this one right here. 3x times 8 is 24x, and so that's just too big. I can't, right, in any way get that to come down to a 10x, okay? So I can try something else. Now, you could try 8 and 1, but giving that a little thought, that's going to produce a what? We're going to get an 8x there and a 3x here, and it's close, right? I mean, you know, if these were, say, you know, both positive, that's an 11x. It's at least somewhat in the ballpark, but again, it's just not going to quite work out. Okay, so let's go to 2 now and 4 and try something there. So, you know, if we try, say, 4 and 2, how about that? Well, we would get a 4x from that and a 6x from that. Hey, that's awesome, right? We need a positive 10x. So if both of these are positive, combining them would give us that 10x we need. So there you go. Okay. Now, of course, the more of these you do, you can kind of speed this process up. And this is just one of those instances where, you know, practice really will make perfect. But yeah, you know, just keep trying a couple combinations, and hopefully you'll land on one soon. And sometimes, you know, like up here, some of the combinations are just going to give you numbers that are clearly way off the mark because they're just either maybe way too big, something like that. So keep that in mind. All right, so now let's go ahead and check out these last couple here. We'll go ahead and do M and N, and then we'll pause. So here for M, well, it's more practice with trinomials, so this is just kind of good further practice. We got 5x squared, so we could try a 5x and an x. Again, nice that it's not too many possibilities there. Now for the 6, well, again, I'm ignoring the sign for the moment. I could have a 1 and a 6, or a 2 and a 3. And my middle term I need to generate, right, is a positive 13x, okay? So let's see here, like 1 and 6, for example. If I tried a 1 and a 6, I'm not even going to write it down, right? Because the 6 times the 5 is going to be a 30x. That's just way too big, okay? What about a 6 and a 1? Well, that'd be what, a 5... Oh, sorry, I meant to write a 6 and a 1. Okay, we'll try that. This would be what, a 6 and a 5? Okay, well, unfortunately, I can't get a 13 out of that, no matter how I assign positives and negatives, so we will scrap that. How about 2 and 3? Well, if I try, say, like a 2 and a 3, that's a 15 and a 2. That sounds promising, right? A 2 there and a 15. Yeah, I can get a 13x out of that. I can get a 13x out of that by making the 2x a negative, so this one would be a negative, and then the 15x a positive, so this one would be a positive, and that would generate that middle term of 13x. So there we go. Cool. And then lastly here for this video, another trinomial. So we got the product of 6x squared. Well, I need a what? Either a 6 and a 1 or a 3 and a 2. Okay. And then here for the 3, fortunately not too many scenarios there, just 1 and a 3, right? So you can see this one, right, with all the others, with a 5x squared, for example, there's just 5x and x, that's one possibility. 6x squared, got two possibilities now, okay? So I'm going to go ahead and jump to the 3 and the 2. Let's just try it. So you got 3x and 2x. And that'd be, well, product of 6x squared, that's nice. And then for the 1 and the 3, okay, so if I try a 1 and a 3 there, is this doable? This would give me a 2x, and this would give me a 9x. Can I combine these in a way to get a negative 11x? Well, the answer there is a yeah, I can. Okay, so if I make both of those negative, that would give me my minus 11x. And so here I want those both to be negative. Okay, so that will do it. Okay. All right, cool. So in the last video we'll look at some examples of things that simply just don't factor, and then these last two are some nice illustrations of how difference of squares and some other a few other details can all be tied together. Okay, see ya.